Arizona is known for its deserts and its iconic red canyons, but few realize that the state's most powerful forces lie deep beneath the ground. Scattered across northern and eastern Arizona are more than 600 volcanoes, silent pyramids of ash and stone that rise from the earth like forgotten monuments. Their slopes are still sharp, their lava fields still young, their craters still perfectly preserved. These are not relics of an ancient world long gone. They stand as silent markers of a fiery past carved into the desert itself. For centuries, these volcanoes have remained quiet, overshadowed by more famous giants like Yellowstone. Yet new geological research is revealing something unexpected. Magma still lingers beneath Arizona. Heat still rises from the mantle. The crust beneath remains warm, cracked, and partially molten. Arizona's volcanic fields are dormant, not extinct, and the last eruption happened within the span of human history. So, what secrets lie beneath this volcanic landscape, and what might they reveal about Arizona's future eruptions? Today, let's delve into the mysteries of Arizona's ancient volcanoes and examine the possibilities of future eruptions. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. Arizona's volcanic story begins deep beneath the Colorado Plateau, one of the most unusual and puzzling geological regions in North America. This vast block of crust, rising more than a mile above sea level, is surrounded on all sides by zones of intense tectonic stretching and fracturing. To the west lies the Basin and Range Province, where the crust has been pulled apart for tens of millions of years. To the east is the Rio Grande Rift, a geologic scar slicing down through New Mexico. These surrounding forces have fractured and weakened the Colorado Plateau, creating natural pathways through which molten rock can rise. Unlike classic volcanic arcs such as the Cascades, Arizona's volcanoes are not triggered by subduction. Instead, they originate from mantle upwelling, crustal thinning, and deep thermal anomalies that slowly feed magma into the lithosphere. As the plateau rose, pockets of magma accumulated beneath it. Over millions of years, these pockets exploited faults and fractures, producing a chain of volcanic provinces across northern and eastern Arizona. Recent geophysical imaging has made the picture even more compelling. Beneath the San Francisco volcanic field, scientists have identified zones of partial melt, evidence that magma still lingers in the lower crust. Rather than forming a single chamber like Yellowstone, Arizona's magma exists as a distributed network of small pockets capable of driving future activity. Studies also show that the crust remains unusually warm, hinting at a persistent heat source beneath the region. Researchers have even proposed a migrating volcanic trend running from southwestern New Mexico, across Arizona, and into Nevada. This alignment resembles a hotspot track, despite lacking a clear hotspot, suggesting volcanism here may be shifting and evolving. This complex geological foundation, a fractured plateau, a warm and weakened crust, and a mantle that continues to supply heat, has created one of the most diverse volcanic landscapes in the United States. Scattered across Arizona are more than 600 volcanic cones, domes, craters, and lava fields, each preserving a chapter of the state's fiery history. The heart of this volcanic landscape is the San Francisco Volcanic Field, a sprawling 1,800 square mile region surrounding Flagstaff. Here, dark cinder cones rise from the plateau, while the towering San Francisco peaks, Humphreys, Agassiz, and Fremont, stand as remnants of a colossal stratovolcano that may have once exceeded 16,000 feet. Built through countless eruptions and ultimately destroyed in a catastrophic collapse, this ancient giant left behind the jagged peaks revered by indigenous communities today. Within the same field lies Sunset Crater, formed in 1085 AD. Its red and black slopes mark Arizona's most recent eruption, an explosive cinder cone event witnessed by indigenous peoples. Ash-buried farmland, lava-burned forests, and entire settlements were displaced, yet the enriched soil later supported renewed agriculture. Sunset Crater remains the most vivid reminder that Arizona's volcanism extends into human time. To the northeast, the Hopi Buttes volcanic field reveals a different eruptive style. Here, rising magma met groundwater in violent steam-driven blasts, creating hundreds of maar craters, broad, low-rim depressions that remain among the state's most striking volcanic features. Farther west, the Uinkaret volcanic field dramatically reshaped the Grand Canyon. Lava repeatedly cascaded down the canyon walls, forming massive basalt dams across the Colorado River. These temporary lakes eventually overtopped the dams, triggering catastrophic floods that tore through the basalt and resculpted sections of the canyon. Some of these eruptions occurred within the last few thousand years. Then, to the east lies the vast Springerville volcanic field, home to more than 400 vents that erupted intermittently over hundreds of thousands of years, producing extensive basalt flows that still define the region. Its size reflects a long-lived magma supply and a crust riddled with eruptive pathways. Together, these volcanic fields reveal a landscape shaped by ancient giants, explosive craters, lava floods, and recent eruptions. A vivid reminder that Arizona's volcanic story is far from over. Although Arizona's volcanoes have not erupted in nearly 1,000 years, its volcanic fields are far from inactive. Modern geophysical tools have revealed ongoing processes beneath the surface that suggest a system still evolving. Satellite radar has detected slight ground deformation across parts of the San Francisco volcanic field. Small movements that do not indicate an imminent eruption, but do confirm that the crust is adjusting to deep pressures and thermal changes. Seismic studies, limited by Arizona's sparse sensor network, have also recorded scattered small earthquakes, the type commonly associated with shifting stresses, and minor fluid movement in volcanic regions. The most significant findings come from imaging the lower crust. Magnetotelluric surveys and seismic tomography show pockets of partial melt beneath the San Francisco peaks, indicating a warm, partially molten environment rather than a single unified magma chamber. This suggests that heat and magma persist beneath northern Arizona, and that the geological engine responsible for past eruptions remains active. These findings have influenced the U.S. Geological Survey's Volcanic Threat Assessment, which ranks the San Francisco volcanic field as a high threat system. The risk does not stem from signs of imminent eruption, but from the combination of an active geological setting, nearby populations, and limited monitoring. Arizona has fewer seismic and geodetic instruments than any other active volcanic region in the United States. This monitoring gap means early warning signs, ground uplift, gas emissions, seismic swarms, could go unnoticed or be detected too late. The evidence is clear. While quiet, Arizona's volcanoes are not geologically dormant, and the forces that shape the region remain very much alive beneath the desert. What would happen if Arizona erupted again? Scientists estimate that eruptions in the San Francisco volcanic field occur roughly once every 1,000 years, and with Sunset Crater erupting around 940 years ago, the region is well within a time frame where future activity is possible, though not guaranteed. A new eruption would likely begin with small earthquakes, as magma forces its way upward, followed by ground deformation detectable by satellites. If the magma reached the surface, it could open a fissure or feed a new cinder cone. The most probable eruption style is basaltic, producing lava flows, fire fountains, and ash columns a few kilometers high. While not comparable to massive stratovolcano eruptions, such activity would still be highly disruptive if it occurred near populated areas. Flagstaff, home to more than 75,000 people, sits directly within the volcanic field. A vent opening nearby could send lava across major highways, severing critical transportation routes. Ashfall could close airports, contaminate water supplies, and, depending on winds, drift as far south as Phoenix. If activity resumed in the Uinkaret volcanic field, lava could once again spill into parts of the Grand Canyon, potentially affecting tourism and river operations. Another possibility is a maar explosion like those in the Hopi Buttes region, where magma interacting with groundwater produces violent steam blasts and large craters. The most difficult challenge is uncertainty. With more than 600 vents spread across 1,800 square miles, the next eruption could occur almost anywhere. This unpredictability makes planning difficult and highlights the urgent need for stronger monitoring and early warning systems. The U.S. Geological Survey and the Arizona Geological Survey continue to monitor Arizona's volcanic fields, but limited instrumentation remains a major challenge. More seismic stations, GPS sensors, and gas monitoring tools are needed to detect warning signs early. Indigenous oral histories also provide valuable first-hand accounts of past eruptions, offering insights into how future events might unfold. For now, the outlook is one of cautious vigilance. Arizona's volcanoes are quiet but not extinct. Magma still lingers beneath the crust, sustained by active geological forces. An eruption is not expected soon, yet it cannot be ruled out. Beneath the deserts and canyons lies a land shaped by ancient fire, still restless in its silence and capable of awakening. When the next chapter arrives, it may come quietly at first, before the Earth once again reveals the power that shaped Arizona's past and could shape its future.